This is PreCalculus 12, Chapter 7.5. We're going to be looking at sum and difference identities. These are a little bit more complicated. We have sine alpha plus beta is equal to sine alpha times cos beta plus cos alpha times sine beta. Cos alpha plus beta is cos alpha times cos beta minus sine alpha times sine beta. And we have the other ones, but these two are the ones that we use most frequently, and you should try to memorize them. And here is a proof of why we can use those formulas, but you'll have to watch that in a separate video, and you should watch it. With these identities, we can combine exact ratios to find more exact ratios. And we have to find these exact ratios from the special angles. And there's only two reference angles, 15 degrees and 75 degrees, or in radians, it's pi over 12 and 5 pi over 12. So we have 15 degrees equals 45 degrees minus 30 degrees. And in radians, we have pi over 12 equals pi over 4 minus pi over 6. And this is quadrant 1. And 75 degrees is 45 degrees plus 30 degrees. And I can keep going on reading all of these to you, but what you want to do is notice a pattern. We are always subtracting 30 degrees from the 45 degrees, and we're adding 30 degrees to our 45s. Okay, and just a reminder, solve. It's okay to use a calculator if it asks you to round the answer. When you're asked to use algebra to solve, you need to use algebra all the way through until you find the angle, and then you can use the calculator for the inverse trig. And whenever it says find exact angle, you must use algebra all the way through. Let's look at an example. Find the exact ratio of sine of 23 pi over 12. And this is going to be difficult at the start, so look at the chart. We see 23 pi over 12 is in quadrant 4. That's 7 pi over 4 plus pi over 6. So we use the sign addition identity. So we have sine 7 pi over 4 times cos pi over 6 plus cos 7 pi over 4 times sine pi over 6. Substitute our exact values. This is negative 1 over root 2. This is root 3 over 2 plus 1 over root 2 and 1/2. So we multiply the numerators, negative root 3 plus 1 times 1. And in the denominator, we have 2 root 2. We can put our answer like this, or we can have 1 minus root 3, a little bit easier to read, rather than having a negative first. So you have a problem if the denominators don't match. Okay, these two terms should always have a common denominator when we're using this identity. Okay, let's look at a problem using degrees. Find the exact ratios for 105 degrees. So 105 is 135 minus 30. So let's do the first one, sine 135 minus 30 equals sine 135, cos negative 30 plus cos 135 degrees times sine negative 30 degrees. Notice I didn't use the subtraction formula, even though this is a subtract. I can treat this as a plus minus. That way I only have to remember the addition identities. Now we substitute our exact ratios, 1 over root 2, root 3 over 2, plus negative 1 over root 2 times negative 1/2. And this gives us root 3. There's 2 negatives, so that's a positive 1, and 2 root 2. Okay, if you don't remember these, just write them down. This is 45. This is 1 over root 2. This is 1 over root 2, but this is negative. This is 1/2, but that's negative. And this is root 3 over 2. Now for cosine, we use the cosine identity. And again, I'm going to use add instead of subtract. Cos 135, cos negative 30 degrees, minus sine 135 degrees, sine negative 30 degrees. Substitute our exact ratios. Negative 1 over root 2, root 3 over 2, minus 1 over root 2, and negative 1 over 2. And we simplify. Negative 1 times root 3 is negative root 3 over 2 root 2. And we have 2 negative signs, so that's plus 1 over 2 root 2. And we combine the fractions, negative root 3 plus 1 over 2 root 2. Now, since we've already calculated sine and cosine, we don't need to use the identities anymore. We can just use the fact that we have sine and cosine. Tangent is sine over cosine. So we will write root 3 plus 1 divided by 2 root 2. And we have negative root 3 plus 1 over 2 root 2. These 2 root 2's cancel out. So we have root 3 plus 1 and 1 minus root 3. We want the positive term first. We don't have to go through the same steps for cotangent. We just take the reciprocal of tangent. So 1 minus root 3 over root 3 plus 1. And cosecant is the reciprocal of sine. So we have 2 root 2 over root 3 plus 1. This is sine. And for secant, we have secant here, so we take the reciprocal of that one. We have 2 root 2 over 1 minus root 3. Okay, so we have exact ratios, but we don't have the special angles. We can still do exact ratios for non-special angles. Find the exact ratio for alpha plus beta given cos alpha equals 3 over 5 in quadrant 4 and sine beta equals 12 over 13 in quadrant 2. Now in this problem, we're not required to find alpha or beta. We just use the trig ratios. So we've done this before. Sine alpha is this piece, and it's negative. So we have negative square root 5 squared minus 3 squared over 5, and that works out to negative 4 over 5. Similarly, cos beta, we have negative square root 13 squared minus 12 squared over 13, so that's negative 5 over 13. Now we have sine alpha, sine beta, cos beta, and we can find out all the other ratios. So if you're not familiar with the identities, I would write them out again. But this is sine alpha, negative 4 over 5. And we have cos beta, that's negative 5 over 13. plus cos alpha. This is 3 over 5. And sine beta. This is 12 over 13. And notice we have 5 times 13, 5 times 13. We have the same denominator again. If you don't have the same denominator, you've got the wrong ratios. This is 20 plus 36 over 65. Simplify that again, 56 over 65. Okay, cos alpha plus beta. Again, if you don't remember the identity, just write it out until you do, and it's faster than looking up your reference sheets. This is cos alpha, so we have 3 over 5. Cos beta, this is negative 5 over 13. Minus sine alpha, negative 4 over 5. Sine beta, that's 12 over 13. Again, 5 times 13, 5 times 13, we have the same denominator. So we have negative 15. There's 2 negative signs, so this is plus 48 over 65. And that simplifies to 33 over 65. Again, we do not need to know the identity for tangent for addition of angles, but we can just use sine and cosine. So we have sine here and cosine here. So this is 56 over 65 divided by 33 over 65. Cancel out the 65s, and we have 56 over 33. For cotangent, we'll just take the reciprocal, 33 over 56. For cosecant, we just flip sine, so that's 65 over 56. For secant, we just flip cosine, so that's 65 over 33. Let's look at a backwards problem. Find the exact ratios of this given expression. Cos 68 degrees times cos 82 degrees minus sine 68 degrees times sine 82 degrees. We have cos, cos minus sine, sine. That is a cos addition formula. So this is cos 68 degrees plus 82 degrees. And that works out to be cos 150 degrees. And that's negative root 3 over 2. And sine 150, we look at our chart and we get 1/2. Tan 150, we can just use sine and cosine, so that's 1 over negative root 3. We cancel out the 2's, and we put the negative sign on the top, so negative 1 over root 3. Secant, we're flipping this one, negative 2 over root 3. Cosecant, we're flipping sine, we get 2. Cotangent, we're flipping this one, we get negative root 3. Another problem, find the general solutions for cos 3x times cos x plus sine 3x times sine x equals negative 1. Okay, cos times cos plus sine times sine, that tells us that we're using the cosine identity. We have cos 3x minus x equals negative 1. We have cos 2x equals negative 1. 2x is our reference angle. 2x reference angle equals inverse cos of negative 1. And that equals pi. Okay, so negative 1's a minimum. That's our x value. X is negative 1 over here, so we're looking at pi. There's only one solution for a minimum value. So this is not prime at all. This is just 2x equals pi. X equals pi over 2. And our period is 2 pi over 2. So it's just pi. So our general solution is x equals pi over 2 plus pi n from the set of integers. And want to note special ratio, one solution. And one last problem, find the exact angle over the domain of -4 pi to -2 pi. We have the expression sine 7x cos 5x minus cos 7x times sine 5x equals -√3/2. When we're mixing sine and cosine, we know this is a sine addition identity. We have a minus sign, so this must be 7x minus 5x. We simplify, we get sine 2x equals -√3/2. Special ratio. (2x prime) equals inverse sine, absolute value of -√3/2. So this is pi over 3, or 60 degrees. And we have sine being negative, so we have an answer in quadrant 3 and an answer in quadrant 4. So our quadrant 3 answer is pi plus pi over 3. That's 4 pi over 3. And now we need to divide by our b value. Our period is 2 pi over 2, so it's pi. So our x equals, we'll divide this by 2, 4 pi over 3 divided by 2, that's 2 pi over 3. And our general solution is 2 pi over 3 plus pi n element z. And now we need to find our answers in the domain. We start with 2 pi over 3. We subtract pi. That's negative pi over 3. That's not in our domain. Negative pi over 3 minus pi. That's negative 4 pi over 3. That is not in the domain. We subtract again. Negative 4 pi over 3 minus pi. That's negative 7 pi over 3. That is in the domain, so we'll box that answer. And we need to subtract one more time. Negative 7 pi over 3 minus pi. That's negative 10 pi over 3. And that's in the domain. Negative 4 pi is negative 12 pi over 3. So we can't subtract anymore. Next quadrant, 2 pi minus our reference angle, pi over 3. We get 5 pi over 3. We need to divide this by 2, so x equals 5 pi over 3 divided by 2. This is 5 pi over 6. So our general solution is 5 pi over 6 plus pi n element z. 5 pi over 6 is not in our domain, so we subtract pi. We get negative pi over 6. That's not in the domain, so we subtract pi. We get negative 7 pi over 6. That's not in the domain, so we keep going. Negative 7 pi over 6 minus pi. It's negative 13 pi over 6. That is in the domain. Because negative 2 pi is equivalent to negative 12 pi over 6. And then finally, negative 13 pi over 6 minus pi. That gives us negative 19 pi over 6. And that's in the domain. And we box that answer. And we're done. Let's just write out those domains. This is negative 6 pi over 3 and negative 12 pi over 3. And over here, it's negative 24 pi over 6 to negative 12 pi over 6. So convert your domain to have a common denominator, and it makes it easier to get your answers. And that completes this lesson.